All right, here we go. I won't record for too long. Don't you love the life lessons you learned from Davidson? I am wearing shoes and a jacket from Ross. Socks from Ross.
I'm wearing shoes from Ross.
Well, there you go. It's the greatest place on earth. Okay, so on page 4, we did the first couple together, and then go ahead and try number 3 and 4 on your own. You will need your naming schemata, probably. You will need your periodic tables. You'll need your colored pencils. So first, write the formulas. Next, make sure the formulas are correct by doing the drop and swap. After that, hey, he's here pretty early, huh? He's doing good. Yeah, your head got really close to just going down, but it's okay. Um, anyway, so write the formula, then do the drop and swap to make sure the formula is correct, then balance, then draw, then color. Everyone, everyone excited?
No.
No, that was just a dumb trick that didn't work. Uh, all right, take about 15 minutes and see if you can do it without my help. Then we'll talk it through. Yeah. Yes. Wow, that was a really short. That wasn't even 15 seconds. What? You just want me to give you the answers? Well, that's not what I'm going to do, but I will give you. All right. So this is mostly right, except we did not drop and swap CaOH, and then also hydrogen. You may remember, and a lot of you got that part right. Hydrogen's diatomic. So anytime you write a formula from a name, drop and swap, meaning take care of the subscripts, and then we balance. So if we go to the periodic table, we would see calcium has a +2 and hydroxide has a -1. So that would mean that calcium hydroxide is CaOH2. Now, a lot of you are making this mistake, and you're putting a 2 there. And a 2 does go there, except it must be in parentheses, because we don't need 2 H's. It doesn't say calcium hydride, it says calcium hydroxide. So we need 2 of whatever comes next, which is the OH. All right, and then double check your periodic tables again, and you would notice hydrogen is diatomic. Okay, this step is the part that kids struggle with. All right. Tori said, I don't remember exactly how he put it, but he said, this is the part I'm worried about, balancing's easy money, or something like that. Right? So make sure that you can balance the formulas. That's what we did over and over last lab book, so we'd be ready for this moment. But that was last lab book, which was a year ago. So whatever. There you go. There's my second 2021 joke. All right. Then once we have this ready, we would balance. These can be confusing when we have water and hydroxide. If you treat hydroxide as a thing itself, then it's easy. So I did this. I don't think I did it for you guys, but whatever. Pretend that OH, it's kind of ugly, but whatever. We're going to pretend OH is a yellow blob, because we could do that. Now, here we go. I need to fix my H2, right? So if I have 2 H's, and look, I just have a yellow blob now, not an H. So I have 2 H's. I need to put a 2 in front of that H. What does that do to my number of yellow blobs? It makes 2 of them. Good. What does this tell me about my yellow blobs? There are 2 of them. So that's a super good sign. I just got to double check to make sure calcium's 1 and, oh boy, and 1. Just, I have a student in my AP class that's doing absolutely nothing but besides playing video games on his phone. His parents just replied to mine, so and so and I would love a Zoom meeting. Whenever both parents show up, that's no bueno. All right, so 1, 2, 1, 1. I 100% know these are hard. Like it's a ton of information to put together. That, I know it sounds weird, but that's the value of doing this, is that you can do hard things. You can practice getting information from multiple places, meaning your naming schemata, your periodic table, and synthesizing them, and then applying another difficult concept. Like, I know you don't like it, but this is actually really good for you. All right, should I just draw it out since half of you are waiting for me to give you the answers anyway? Yeah, okay, well, what a great time to be alive. All right, I have, tell your partner at least, make noise right now. How many are going to draw one thing? And what is that one thing? It's a calcium. All right, plus, tell your partner, how many things am I going to draw? I'm going to draw 2 things. And those 2 things are what? H2O and the water. We usually write it like this. Now if you didn't put it like bent like this, it's fine. Just whatever way you wrote, then we should be good. Okay, then an arrow. All right, now, how many things am I going to draw next? Just 1. This coefficient tells me how many things I'm going to draw. Now, it's a complicated thing I'm going to draw. And look at as I say this, it's a single calcium that's bonded to 2 things, and the 2 things are O's and H's. So let me put that together. I'll draw it as I say it one more time. I'm going to draw a single thing, which is calcium, but the calcium is bonded to 2 things. So I'm going to put a line on both sides, and the 2 things it's bonded to are an O and an H. You okay with that? Like, you can see that it's right there. Plus, a little out of room here, I draw one thing that is 2 H's connected to each other. Fair enough? Okay, then I would color. You can go ahead and color. I'll like highlight. So we'll say calcium is this color. And we'll say oxygen is this color. Then I get a genius their parents want to come talk to. Well, I kind of like this highlighting tool. I don't use it very often. Oh, I forgot the. All right. Now, why am I making you draw and color? It's so you can see the balance. You can literally look up there and you can see, hey, on the left side of this line, I have 4 H's. 1, 2, 3, 4. On the right side, I have 1, 2, 3, 4. Definitely they have rearranged themselves, but definitely they are equal. The law of conservation of matter says matter cannot be created or destroyed, but it can change forms. So we didn't create or destroy it, but we rearranged it. All right, 2 green, 2 green, 1 yellow, 1 yellow. This would be balanced. Got it? Okay, number 4. Whew. I'm not going to give you a ton of time. Will you try it at least? It's interesting. We're halfway through the try now, and I mean, we have people that are putting in effort, and we have people that have not put in effort. All right. Someone remind me to unpause this when we start. I have a feeling I know who that will be. Extremely talented, and his father is not. So, all right, here we go. If I were you, it really will help you if before you really do anything, you find the charges of these things. Now, hydrochloric acid is just a formula from the chart, right? But if you would just look at your periodic table real quick, you're like, okay, I know aluminum's a +3. I know oxygen's a -2. Hydrochloric acid, my table just tells me is HCl. I know aluminum's a +3. Chlorine is a -1. And I know water is HOH. Well, I'm going to put H2O this time. Why did I put H2O this time? Because I don't have hydroxide. Bottom of page 4, my friend. Okay, now, the reason why we put those charges up top in the first place is to just save us time. So we already know how to drop and swap. So aluminum is Al. Oxide is just oxygen. So then the 2 goes with the Al. The 3 goes with the O. Now we've done that a few times. It's the third time actually we've done Al2O3. So hopefully that you are okay with that. Aluminum chloride, aluminum +3, chlorine -1. Drop these numbers. So it's AlCl3 plus H2O. Fair enough? Okay, now this one, you can start. I don't know. If you follow my rule to start with the highest number, there's 2 choices. If you follow my, not rule, my idea to start with the metal, that makes it go fast as well. The one that's tricky, if you start it with Cl, life will get a little tricky. So I'm going to start with O. Really, I would have started with Al, but who cares? O is a 3. This is the only place there is oxygen, so I need 3. Now that takes care of oxygen, but it makes how many hydrogens? 6. So then I must put a 6 here. That makes how many chlorines? 6. So there's already 3, so I must need a 2. Then I'm to where I started and I put a 1. This is what goes wrong. If you start with H here, not H. If you start with Cl, you get a 3 right here, right? So you're like, all right, I'm going to put a 3 in front of this. And then you come over here and you're like, oh, wait, this has got to be even. So really, this has to be a 6. Does that make sense? So like you can do it, but you'll have to come back a little bit and work things out. If you start with the metal, you have 2 aluminums. You know you need 2 here. That means you need 6 chlorines. That means you need 6 hydrogens, and you're good to go. So really, you could start sort of with any of them. One made it a little bit trickier than the other. All right, drawing this. Hopefully, you're okay drawing Al2O3. We're going to draw one thing, which is 2 things connected to 3 things. We've been doing this for weeks. If we ever have a 2 to 3, we build like that little diamond formation. We have an Al, and then we'd have the 3 things in the middle. And I only need one of them because this coefficient's 1. Then plus, I need 6 things, and the things I need are an H bonded to a Cl. We all right so far? Okay, the next thing we draw 2 things, and the 2 things are AlCl3. So I have 1 Al, and it's bonded to 3 chlorines. If your structure looks different than mine, it doesn't matter at all. So don't stress about that. And then I need 3 H2Os. Then I'd color. Well, look at that. I just put 2 yellow things on both sides of the arrow. That means they are balanced. I have 3 green things on both sides. That means they are balanced. Six blue things on both sides. That would mean they are balanced. Good answer. And then I finally have my chlorines. Nice purple Friday. They don't do that anymore, but we used to have purple Fridays every Friday.
How many people would actually wear purple?
90%. And I'm not saying like you guys are bad humans by any means, but the school pride used to be way, way high, and everyone wore purple on Friday, pretty much. Now, I don't think people care. They do not even know the song, but no one really knows the song without reading the sign. I know it. You know it.
I hardly know.
Bella knows it. I guarantee Amber knows it, and that's probably about it. They taught it to us as a faculty like the second year I was here. We used to sing it at every assembly. I mean, we still probably do. We just haven't had assemblies in a year. So it's, wow, that's crazy to think. It's been a year. I mean, I know it hasn't, but it's close to a year. All right. This is a balanced equation from a formula. In my opinion, this is the hardest part of the entire year. I know that sounds like hyperbole, but this requires the most like collection of information, synthesis of information, and then skill. So I am aware that these are tricky. So let's do more practice. We won't color really anymore, but turn to page 12, the very bottom. And let's see, here we go. We got number 11 and 12. Ooh, that's so quiet. Okay, so 11 and 12. Hey, my man, Kobe, he's doing good today.
I checked in on both of those because they like to fall asleep.
They do have some similarities in their sleepiness. What's that? It's in your blood.
It's a Kobe thing.
Well, they don't even spell their names the same.
It's still a Kobe thing.
Okay.
Right, Kobe? Yeah. See, they all said yes. Actually, one nodded, the other said yes.
You're the no L one, right?
Yeah, I'm the no L.
You're the original. Okay. All right, let's work on 11 and 12 together. Whoops, that was the wrong line. I apologize. Okay.
Not worth it.
My wife, I sent her like a nice memoji this morning, and all I get is a typed "I love you too." Does that mean she doesn't really love me? I'm so confused. Okay, here we go. If I were you, once again, I'd be running cross country, singing in choir, and being the lead in the play. Wait, that's my child. If I were you, I would put the charges of things above what they are. Aluminum, you can find in your periodic tables at +3. Oh crap, hold on. Don't do that. Okay, you're like, Tom, you just said something, but now you're lying. Yeah, oh, I'm like your parents, okay? These are just elements. I'm sorry, I didn't look before I started writing. You don't need to put charges above elements. You put them when they're in formulas. So aluminum chloride, that's like a formula. So +3 here, -1 here. So now we should be ready to go. You can either do it above or below, it doesn't matter. I'm a below kind of guy. Here we go. We go Al plus Cl. And then I should always check what about single elements? Are they diatomic? Is aluminum diatomic? No. Tell your partner how you know that, please. Yeah. If it doesn't have a 2, do you have a periodic table? All right. If it doesn't have a 2, then it's not. If it does, then it is. Chlorine is diatomic, right? Okay, then your arrow. Then we have the charges to make life easier for us. We already had them. Aluminum and chlorine. We already did this one a minute ago. AlCl3. Then we have to balance. So, I don't know. I'm just going to say there might be a swaparoo in your future. Oh no. Is there a problem, young man?
No, I just gotta do more work. So
Yeah.
it's not really a problem, it's just a setback.
Okay, here we go. If you see a 3 and 2, you should do the swaparoo. The 3 goes in front of the 2. And remember, we're just trying to make them both equal each other. And to make a 3 and 2 talk to each other, we make them 6. So 3 in front of the 2, a 2 in front of the 3, that makes that 6. And then that off balanced, is that even a term? Well, whatever, I guess it is, whatever. It made the aluminum out of balance, so you're gonna put a 2. 2, 3, 2. Now, this one would be considered, as far as these are concerned, this would be an easy one. This one would be a medium one for sure. Now, I know we're out of time, so let me just do this one for you. All in favor, say aye. All right, sodium +1, hydroxide -1. Sulfuric acid, I just look at the chart and it says H2SO4. My arrow, sodium +1, sulfate -2. Water, I know, is HOH. Anyone know why I wrote it as HOH? Hydroxide, good answer. So now I'm going to put the pieces together. Sodium is Na. Hydroxide is OH in a 1-to-1, so I don't need parentheses or anything of the sort. Over here on the right, sodium is Na. It's a +1. Sulfate is SO4, but I need 2 NAs to offset the charge. Then I'm ready to roll. I just balance. I'll just start with the metal, 2 NAs. So I need 2 NAs. That means I have how many OHs? 2. So I put a 2 in front of water. That makes 2 H's, but I have 2 H's, so I'm done. Whoa! I love it when I end on a perfect minute. All right, you guys are amazing. Get out of my room. Have a safe weekend. If I were you, I would lock yourself in a